Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're talking about types of function in calculus, and we'll be talking about the three broad types of function, okay? Please, like I always say, make sure you've liked, subscribed, and shared this video. And if you've not clicked on the notification bell, I don't know what you're waiting for. Please do so that when I post new videos, you'll be the first person to know. All right, so let's get started. So we're going to start with the first one. So I'm going to quickly just introduce the three broad types of functions. So there are three types. We have the increasing function, we have the decreasing function, and we have the stationary point, okay? So there are three types. We have the increasing function, we have the decreasing function, and we have stationary point. So the increasing function is basically some textbook just have subset. When you go to some textbook, you will see types of function and subsets of types of function. They have two subtypes, but I'm going to just I'm going to list both of them, but I'm going to focus more on stationary points. So I'm going to give a brief overview of an increasing and decreasing function, but I'm going to spend more time. I'm going to make more videos on stationary points, on how to find the coordinates of a stationary point, and also on how to find the nature of a stationary point. So let's quickly write down, because I know some of you do take notes. So there are three broad types. There are three broad types of functions, okay? And two subsets, okay? So you see some textbook will also say there are two subsets, and there are several, but I'm gonna just focus on two subsets. So the first one is what we call the increasing function. So increasing function. So increasing function, it means that dy over dx is greater or equal to what? 0. So when you differentiate and is greater than equal to 0, is called an increasing function. But there's a subset of this which is called strictly increasing function, okay? It's called strictly increasing function, okay? So this is a type of function in which the dy over dx is greater than what? 0. So you will see in some textbook, you will see increasing function. In some textbook, you will see something like called strictly increasing. So technically, it's a subset of the increasing function. Then in number 2, the next one we have is what we call the decreasing function. Okay, decreasing function. Here, the y over dx is less than or equal to 0. But in some texts, you will see what we call strictly. So this is the second subset. You see what we call strictly decreasing. All right. You will see strictly decreasing what? Function. In this case, the y over dx is going to be less than what? 0. All right. Then number 3, we have the last one. We have what we call the stationary point. Okay. The stationary point is the third type of function. Here, the y over dx is equal to what? 0. So these are the three broad types of what? Function. So in calculus, we usually use the derivative, which is the dy over dx, to check whether a function is decreasing, increasing, or stationary point. So basically, in order to know if a function is an increasing function, the first thing you have to find is the dy over dx. So you see, you need to make sure you've reviewed my video on the mechanism of differentiation, so you know how to differentiate. So now what you do basically is that you differentiate, and based on the value of your derivative, if you equate it to 0, it's a stationary point. If it's greater or equal to 0, it's increasing. Less than or equal to 0 is decreasing, okay? If it's just greater than 0, it's strictly increasing. If it's less than 0, it's strictly what? Decreasing, okay? Because of this is an overview, I'm going to just quickly give a general comment for each of them, okay? So general comment, but in the next video, I'm going to be talking about them individually, all right? So generally, let's assume we have a function of y is equal to f of x, all right? Now, let's start with the first one. So if the value of y you have increases or keep on increasing based on the value of x, the function is known to be increasing. So basically, when y keep on increasing, as you're increasing the x, the function is said to be what? Increasing. So basically, I'm going to write it down. So if the value of y increases, okay, the value of y increases on increasing the value of x, so if the value of y increases on increasing the value of x, then the function is known as an increasing function. Okay, so when you're increasing x and y is also increasing, that function is known as an increasing function. So for instance, you have something like this. So this is how it looks like. So for instance, f of x is equal to the exponential of x. It's a classical example of an increasing function because as x is increasing, y is also what? Increasing. Are you seeing it? So this is what we call an increasing function because as x is increasing, y is also increasing. Now, but the opposite now is what we call the decreasing function. Now, for decreasing function, the value of y decreases when you increase the value of x. So it's the opposite here. So now, if for instance, if the value of y, okay, decreases on increasing the value of x, okay, then the function is known as decreasing function. Okay, so this is basically the opposite of an increasing function. So basically, it looks like this. So a decreasing function looks like this. Are you seeing it? So what happens is that as the value of y decreases, the value of x also what? Decreases, okay? All right? So this is what we call a decreasing function. So as the value of y decreases on increasing the value of x, then this is said to be a decreasing function. A classical example for this is an f of x is equal to ln x, all right? And f of x is equal to ln x. Some textbook can draw this another way. It can draw it all going down. So depending how you want to look at it, like for instance, you have different points of it. But yeah, so but basically what you need to know for a decreasing function is that the value of y decreases, the value of x will be increasing. So as you're increasing the value of x, the value of y is decreasing. Now, but the most important one that I want to talk about is the stationary point. Now, a stationary point is a point where the derivative of dy over dx is equal to 0. So a stationary point of a function, okay, f of x, all right, it's a point where the derivative is equal to 0. All right? So a stationary point is a point where the derivative is equal to 0. So that means we're talking about the dy over dx is equal to 0. Now, a stationary point looks like this. So you can draw the graph like this. All right. So if you have this graph, or you have some textbook can draw, you can have something like this, all the way down to this. Or better still, let me use a different color so that it will be very, very prominent. So we have, let me use a blue pen here. So we have the graph looking like this, okay? Then let me draw this one here. All right. So we have the graph as well for this one. We have it looking like this all the way to this point. Like this, all the way to this point. And like that. Okay? So now the stationary point, the point that our stationary point is this point here, this point here. At this point, the y over the x is equal to 0. This point here, this is a stationary point. This point here is also a stationary point. And this point here is also a stationary point. And there are three types that we're going to talk about. I'll talk about the nature. We'll talk about, it could be a maximum stationary point. I'll talk about that very soon. This is a maximum stationary point. It could also be a minimum stationary point. So this is an example of what we call a maximum. Don't worry, I'll discuss each of them. I'll have individual video series for this. And this is a minimum. And also we have what we call the point of inflection. Okay, the point of inflection. So a classical example is this. So this is what we call the point of inflection. All right, and that is that for that. So basically, there are three types. So when you have an increasing function, so it means that if for this one, the y over the x is greater or equal to 0. Okay, this is an increasing function. A decreasing, the y over the x is less than or equal to what? 0. The same thing for this one, stationary point, the y over the x is equal to what? 0. Okay, and that is that for that. So the next video, I'm going to talk about the increasing function. I'm going to talk about increasing and decreasing function quickly. Then after that, I'm going to spend more time on stationary point. On that stationary point, I'm going to talk about how do you get the coordinates of a stationary point? How do you find the nature of a stationary point? Okay. All right. So that is that for that. Okay. So I'll see you in the next video where we talk about increasing and decreasing function. So it's very important that you try as much as possible to subscribe and click the notification bell so that when I post the video on stationary point and increasing and decreasing function, you'll be the first to know. So I'm going to see you in the next video. See you soon.